Alright, so today we are going to have you do watch this video so that tomorrow in class we can go right to answers and getting this stuff. Plus, this is stuff that you've already seen multiple times. Okay? So today we're going to work on solving linear systems of equations. There are 5 ways to solve systems of equations. Today we're going to focus on the first 3 of them, and then later on in this unit we will get to the other 2. So the 3 that we're going to focus on today are going to be graphing, where you put both lines onto a Cartesian coordinate system and then find the intersection point. Substitution, where we're going to replace one of the variables with another expression. And elimination, where we're going to eliminate one of the variables. The other 2 that we're going to get to later on are inverse matrices and Cramer's rule. Okay. So, first one, solve by graphing. When we're graphing, we need to treat each one individual. Okay. So I'm going to deal with this one first. X minus 2y equals negative 10. In order to graph it, I'm going to solve that for y. So I'm going to subtract x from both sides and then divide everything by negative 2. So that's going to give me y here equals positive 1/2 x plus 5. On the graph then, I'm going to go up 5 from the origin. That's my y-intercept. And then my slope of 1/2 is a rise of 1, a run of 2 from that y-intercept. Or I could go the other way and go down 1 and left 2. And then that becomes my line. I want it in the blue and I want it to be solid. So there is my line. Okay. Then the other one, I'll do in red. X plus y equals negative 1. So y is going to be negative x minus 1 when I subtract x from both sides. So that has a y-intercept of negative 1, and then I go down 1 and right 1. Or I could go up 1 and left 1. Okay. So those 2 intersect right here at the point negative 4, 3. Okay. And then we can check that back in both equations. Negative 4 minus 2 times 3 is negative 4 minus 6, which is negative 10. So it checks out in our top equation. Negative 4 plus 3 is negative 1, so it checks out in our bottom equation also. So there is our intersection point. That is graphing, putting both lines on the same Cartesian coordinate plane. Substitution has some steps with it. Okay? The first step is you want to isolate one of your variables. Now, in this particular case, that was already done for us. The x here is isolated in that first equation, so it's equal to 2y minus 1. The second step then is, in the other equation, substitute for that isolated variable. So I'm going to put into that equation what my x value is. So that's going to be 3. And then now instead of x, it's going to be 2y minus 1. And then minus 4y is equal to 5. Okay? So then we solve for that particular variable. So here I could distribute in that 3. So that's going to now give me 6y minus 3, still minus 4y, still equal to 5. So that would become 2y minus 3 equals 5, which is 2y equals 8 when I add 3 to both sides. And then when I divide both sides by 2, I get y here is equal to 4. Okay? So then I take that and I solve for the other variable. So now I'm going to put this 4 back into one of these two equations. I'm going to go into the top one, and that's where that's going to be. And then that's going to give me the answer as a point. So if I went x here is equal to 2 times 4 minus 1. Oops, missed it. There it is. Okay. 2 times 4 is 8. 8 minus 1 is x here is equal to 7. So my answer then is going to be the point 7, comma 4. And once again, I check that back in both of my original equations. 7 is 7. 2 times 4 minus 1 is 8 minus 1, which is 7, so it checks out in the first equation. 3 times 7 minus 4 times 4. 3 times 7 is 21. 4 times 4 is 16. 21 minus 16 is 5. It checks out in both equations, so then therefore that is my solution. The third way that I'm sure that you guys are more than familiar with is elimination. The first step in elimination is we need to get opposite coefficients on one of the variables. So in this particular case, looking at it, I would multiply this bottom equation, the entire equation, by negative 2. When I do that, I get negative 8x minus 2y equals positive 4. It's got to go into all three parts. That last one going to the other side of the equation is the one that is 9 times out of 10 forgotten. Okay, you got to multiply it all the way through. Then I can rewrite the top equation, 3x plus 2y equals 11. And now here I've got a 2. Oops, let me put it in a color so that you can actually see it. So here I've got a positive 2 and a negative 2, actually, or negative 2 and a positive 2, depending on which way you're looking at it, as my y coefficients, so that when I go to add both of those equations, my y variable gets eliminated. And I have negative 5x equals 15. Then what I'm going to do with that is I'm going to solve for that variable. I'm going to divide both sides by negative 5. And that's going to give me x here is equal to negative 3. Now, just like with substitution, now I'm going to solve the other variable for that one. So I'm solving for y. So let's go into this bottom equation here. So let's go 4x. Oops, pardon me. Let's go 4 times negative 3 plus y equals negative 2. So I'm plugging it back in to one of my original equations. Doesn't matter which one. Okay? And then because I want to get it as a point again, so then this becomes negative 12 plus y equals negative 2. Add 12 to both sides, so then y here is equal to positive 10. So my guesstimate point is the point negative 3, comma, positive 10. And once again, I check that answer back in my original equations. 3 times negative 3 is negative 9. 2 times 10 is 20. Negative 9 plus 20 is positive 11, so it checks out in the first equation. 4 times negative 3 is negative 12, plus 10 is negative 2, checks out in the second equation. So therefore, that is the solution to my equations. Thanks for playing along. We'll go over any questions you have on these tomorrow in class, along with finishing up Chapter P and getting ready for our test on Friday.